Greetings everyone, it's me again, Lorenzo, presenting on behalf of my colleague Obiols-Rabasa, which couldn't be here today. The topic of this presentation is lesson learned of our first CubeSat and their application to our second CubeSat, which I described in my earlier presentation, and their application to our following CubeSat projects. The outline is as follows. Description of the ESTAR program at Polytechnic of Turin, lesson learned divided into educational, management and technical, then a few examples of their application. So ESTAR program was launched in 2008 with the acceptance of our proposal for the Vega maiden flight. From 2009 to 2011 we designed, developed, integrated our first CubeSat. The launch happened in 2012. The launch was very successful. Unfortunately, our satellite suffered malfunctionings. We received the signals, but we never decoded any telemetry, actually. In 2013, we got accepted within the Flying Satellite program with ESTAR-2 as a follow-up of ESTAR. And now we started to perform functional tests for preparation for the environmental test campaign that should be performed in the following months. ESTAR program is a quite large program, as involved a lot of students during all these years. Currently we have more or less 20 members in our team, from PhD students to temporary students who joined the project for maybe 6 months. A few proceedings in training, conferences, workshops, abstract papers have been produced. So, for the management point of view, we found a few lessons learned that could be applied in the case of CubeSat. Few things that are actually quite too large or have timings too large for CubeSat. One example could be frequency registration. This is the schedule proposed during the Flyer satellite program. That's a big timeline. For CubeSat it might be shorter. Documents production. Other presenters also underline these aspects. There is the need to transfer the knowledge from one student to the following. Actually, we were required by ESA to produce really a quality level of documentation for this Flyer satellite program, and this is something that helped us into this transfer of knowledge. Again, we found out that having a well-structured team is a key characteristic of a well-management program. Now we are structured more or less in this sense. We have, apart from the principal coordinator and the main system engineer, we have PhD students guiding the temporary students participating in our team. Moving to the technical lesson learned, there are a lot of lessons learned from ESTAR-1. We found out that basically we need to develop another bus platform for our future project. For ESTAR-2, we needed to completely redesign the internal algorithms, both from the attitude control system, determination control system, and the command data handling. Again, we had to improve our simulation technology. This is related to the presentation I did this morning. We found out that maybe ECSS was too strict or was not really covering the necessities of CubeSat and maybe needed some tailoring. And again, we really improved our mobile ground control station in order to have increased testing capabilities during the development of our CubeSat. Design, manufacturing, and AAV. Our first CubeSat was really complex internally. We tried to simplify the structure, internal structure. again, we found a few difficulty on standard application of standards. And we try to involve more the students in the preparation of the environmental test campaign. And we performed a few modifications on the satellite in order to be compliant with the requirements coming from ESA for the Flyer Satellite program. One example is the relay. Our CubeSat was not able to be turned on from the distance, so we inserted a relay bypassing basically the deployment switch. And also the thermocouples, for the first satellite, we had the thermocouples installed externally. In this case, we are putting them inside. This is the waterfall plot for our Star 1. We never managed to decode any telemetry. A few reasons have been identified. Mostly, the main reason should be that batteries have failed, and possibly because of high temperatures, the batteries were never been tested in space, never flown, so this should be the main reason. But we never managed to debug this information, so this is just an assumption actually. In addition, we define new operative modes for our following CubeSat. Nevertheless, we are really happy about the success of our program by the educational side, in the sense that a lot of students have gained and some experience in satellite development. And we are continuing, and we are trying to expand our program by developing the ISTAR 2, which is almost close to being ready for launch, and also we are developing, designing our first 3U CubeSat 3-star. So just three examples of problems that we had on ISTAR 1 and how we fixed it. First example, on the top, magnetic torques, they were inside in the first version, and now they are outside behind the solar panels. This provides really a lot of easiness for the mounting of the magnetic torques. Okay. Then for the internal deployment system, we changed the resistors. The original ones turned out to be a lot heavy on the consumption, so we have replaced them. And also the batteries have been changed, so we should have more reliable batteries right now, and we will see what happens. Again, this is the thermocouples being installed inside the satellite. And this is the relay modification we had to do in order to be compliant for the thermal vacuum test we will do probably next month. Regarding the few modification we did was new operative modes have been defined, a fail-safe mode has been implemented, also new telecommands have been implemented. For the modification on the main onboard computer, complete refactoring of the code, we added more telemetry information that should help us check the status of the satellite, and then modify the behavior to some commands and increase its reliability and performances. Regarding the attitude determination and control system, again here major refactoring and redesign of all the algorithms. Right now we have modified them. Our system includes carbon filtering on gyro measurements and magnetometer measurements. We redesigned the algorithms for the control, and we are using the BDOT and PID control. And we updated, of course, the models that we have inside. For example, magnetic field model, orbital models, and gyros and magnetometers models are way more accurate this time. Communication system modification here as well. we introduced a beacon signal in case of failure on the communication between the command data handling system and the communication system. And the circuitry for the antenna opening has been moved. It was before on the attitude determination and control board, now it's on the ComSys board. So all in all, these are the conclusion. We gathered a lot of experience thanks to our first satellite. The team, at least the PhD students, well, who are now the PhD student, also worked on ISTAR-1, so the team has remained more or less the same, and the experience has been kept inside the program. And that's all. That's all. We hope that our ISTAR-2 CubeSat will perform well in the environmental test campaign at Flying Satellite Test Tech. Thank you.
Thank you very much. So if you have any questions, now look around. So if there are none, I will close the session. I would thank you again and also all the other speakers.